Computer. Okay, so welcome to week 3, day 3. Today we are going to be covering a topic that is going to be maybe difficult to grasp, difficult to understand at this point, especially if you're new to coding. This is somewhat abstract at times. Recursion is what we're learning about, and it can seem somewhat abstract, but we're going to introduce it today in a way that hopefully will kind of let you understand what's happening in recursion and what we're trying to accomplish and how we get there. So right off the bat, this README is great for walking you through how we would manipulate going from a function that we're solving. Let's see, this is getting the max out of all the numbers and walking you through how to end up in a recursive problem. Please read this in your own time, but I am going to take an alternate path in teaching this and try to break it down a little bit simpler so that hopefully you can understand a bit better here. So we're going to just end up on a blank page here. First off, have y'all been introduced to recursion up to this point at all? Do we know what this is at all? No? No, not even in pre-work or anything?
Oh,
It's
yes, I
another
do.
way to code, right? Sorry. Go, Cisco, you know better than me, man.
Oh, well, I was just Go ahead, Joe.
I just saw it as like another way to solve like different coding challenges. So when I was looking up like there's it just popped up as a more simple, not simple to understand, but a simpler way to code something. That's just how I saw it. But I was like, all right, I don't have time to figure this out, so I moved past it. That was all I got out of it.
Okay, awesome. That's definitely a big part of why we use recursion, simplicity. But we'll touch on that in a bit. Cisco, what do you have to say? What do you know about recursion,
Oh,
if anything?
well, well, yeah. Well, we have used it. I don't know if you guys recall. I believe one of the challenges that we initially had to uh, uh, take before starting this course it was a recursive function. It was the Fibonacci one. Um, Basically, it's just when the function calls itself, and it recursively calls itself a repeated number of times until it completes whatever processes you have in place for it.
Awesome. Yes, that's exactly it. So it is basically going to be some sort of function. Again, we're not that we pass something into that somewhere within this function, we're going to call that same function that we've just defined again with something in here, X, Y, whatever we want to throw in. And then so we're basically nesting the same function within itself, and that sounds weird, but we're going to look at how that works here. Okay. So there are two main things we need for a recursive function. Oh gosh. So recursion is, as Joe said, we're trying to get to something simpler. We're working through a problem to try to solve it in a simpler way than maybe we would do with something else. So we usually have two main cases with a recursive function. Does anyone, okay, what do I mean by cases in a function? What do we think? Let's see. So what am I talking about when I say I have two cases in a function? What do we think that means?
You have a base case and a terminating case or
Okay,
ending case.
so that is what I'm going for at the end here. What do these cases look like? And like what kind of logic are we using for these cases? I don't
It
know
can
if I'm
be
good.
it can be a conditional statement starting out, or like a if if else statement, something like that, something simple like that.
Yep, exactly. So when I'm talking about cases, I'm talking about like a conditional type thing. So I'm having two scenarios. If something meets this, then we do something, right? Those are conditions. Those are different cases. So we usually have two cases for each recursive function. And that is, like Cisco said, we have a base case. Again, we're just pseudocoding here because this is not proper formatting or names or nothing, but it's just to help you all get an idea of what we're looking at. So we have a base case, and it will typically like be an if statement, if base case, then do something. And then we also have, you said a terminating case. What does that mean?
Well, you just so essentially you want to continue to call the function until you come to a false condition or zero or a false condition or something like that.
Okay, good, close. Well, that's along the lines we're thinking here. We want to keep calling this function until we reach, like you said, zero, or the like end of it, basically, which we are saying the end is going to be our base case. So every recursive function has a base case, and this is the end. So usually instead of then do something, this means then stop. Should clarify that there. The recursive case is the proper form here. If recursive case, this is where we're going to kind of work our way towards the base case. Okay, so this is all very abstract right now. We're going to start plugging into real scenarios here in a minute, but each recursive function has a base case where we stop calling this function in itself, and then a recursive case, which is where we kind of break this problem down, trying to reach this base case. Okay, so we're going to comment this out and start looking at a real example. So I want to count down from a number that I'm going to give a function. So we're going to have this function, we're going to name it countdown. We're going to pass in a number, some sort of integer here. I want to write something that will count down and just print those counts on the screen until we reach zero. And then it's going to be like done. Okay. So how we think about solving this recursively is you try to think of the most simple input you could put in here and what that gives in return. So, or where you want it to stop, in other words, too. So if I want to count down from a certain number, what should be like my final instance of this function? What would go in here that would cause this countdown to stop?
The number you want to stop at?
Okay, so if I want to count down to zero, and then at zero it says, hey, you're done. So then what would be the input here?
N equals 0.
Yeah, it would just be zero. So this is how we define our base case. This is where we want this to stop. So we've decided we want to count down from some number down to zero. Well, if we call this function with zero, we expect it to return, and we're going to have it print a statement like done. So that's where we write our base case. If our number is, we'll cover all bases, less than or equal to 0, we want this to stop. We want it to be done. We're just going to say print done here. Typically, you could put in a return, but we're going to build up slowly. So if we reach 0, less than or equal to 0, we're done. Okay, that's our base case. That's the last possible place we want to reach in this countdown. So now we know where we're stopping. but we're passing in a larger number. We're going to give it like 10. So now we have to account for what happens with these other numbers. And how do we reach our base case with that? Okay, so now let's think about every other scenario. Okay, so it's usually an if-else here. So if I pass in 10, it's going to come down here to our base case, and it's going to say, I am not less than or equal to 0, so I'm not done. Cool. So what first do we want to do? If we want to, I want this countdown to print to my terminal each number all the way down to 0, and then at like when it's 0, I want it to just be done. So we've got the done. So if I pass in 10, what do I want this function to do immediately with that 10?
Subtract 1.
Okay, I could subtract 1, but I want to see this number on my screen first. Like I want to see this in the terminal. So how do I just...
You can, yeah, you can, well, you can do n minus equals 1 and then print n each time.
Okay, so if I do n minus 1, and then I print n, let's, for simplicity's sake, let's do the print n first, okay?
Okay.
Because that's the first thing I want to do, right? I give it 10, I want to see 10 on my screen as the start of my countdown, okay? So I pass in 10. First thing I want to do is print 10. Give me 10 on the screen, so it's going to be our number. Okay, cool. So I've got 10 on my screen now. We've printed it on my screen. Now, how can I do the same thing? I want to print the next number on my screen without calling this again, like doing something outside of, I can do it right here. How can I get to 9 and make it print 9 on my screen? So right now we have this, if I call this function and it's anything but 0, it will print the number on the screen, right? We've already defined this function. So if I call countdown with 10, it'll give me 10. If I call it with 9, it'll give me 9. If I call it with 7, so on. So how can I get this to print the next number down? And we touched on, Cisco said this before, and even Art did, I think.
Print n minus 1.
I could print n minus 1. Let's try that. So then what happens after this? So it does print the number, but then I'm going to have to keep doing print statements on the screen here. And then also, it won't automatically stop when I get to 0. It'll just keep printing whatever I tell it to. So this is where we have our recursive case, is where we typically call the function we're working in again, but break it down to the next step, okay? So I want to print n on my screen. Well, countdown already prints it. So I'm going to call countdown. But if I pass in n, it's just going to be 10 still, right?
Right.
So then it'll keep printing 10 and then calling it again with 10. It'll keep doing this loop because it's not doing anything here. So how can I get this to instead print the next number down in this list? Well, y'all said it with the print statement, so I'm going to go ahead and just do it.
Yeah.
We can just simply subtract 1, right? So here we've called countdown with 10, okay? Doesn't meet this criteria, so we're skipping. We're coming down here, put 10 on our screen with our print statement. Next, we come to countdown. Art, you have a question?
Yeah. Is our goal to show like 10, 9, 8 all the way down and then show 0?
Well, I've got it set so when it hits 0, it's just going to tell me done. But
Okay,
yes, the
so
goal is 10, 9, 8, 7, 6, all the way down to done.
and just so I understand, this will actually result, if you printed this now, it would result in like 3, 2, 1 done.
Okay, if I printed this now with what input here?
Oh, well, even if you use 10, I'm just trying to figure out if this will actually give you 3, 2, 1, 0 done, or will this give you 3, 2, 1 done?
Well, let's take a look through it logically. So we'll start with 3. Okay, so put a pin in that. We'll walk through it in a second here. I just want to make sure we have our recursive case correct. Okay, because last time when we just had an n, let's say n was 3, we have 3, we were printing 3, and then we were calling the same function again, but with 3. I didn't want to do that. I want to call it with the next number down so I can see the next number on my screen. So we subtract 1. So now, okay, we put in 3. We print 3 because it doesn't meet this criteria here of being less than or equal to 0. So we print 3. Now I want to do the same thing, but with 2. So n is 3. We've defined n as 3 up here when we passed it in. We printed 3 here. Now it's plugging 3 in for n right here, subtracting 1. So essentially it's saying, all right, call countdown again with 2 now. Okay, cool. So we come back up, countdown. Now n is 2. Okay, so now n's 2. Is 2 less than or equal to 0? No. So we come down here. We'll print 2 on the screen. Okay, now we're coming and we're going to call this again, but I don't want to call it with the same number. I want to go down 1. So now we're going to call countdown with 1. 1 comes up here. Now n is 1. And I can step through this in a minute in the debugger and we'll see this. Okay, so n is 1. 1 is not less than or equal to 0. So we print 1 on the screen. And then we call countdown with 0 because 1 minus 1 is 0. Come back up here. Countdown with the input of 0. Is 0 less than or equal to 0? Yes. So it's going to print done. Okay. So if I put in 3, what should I see on the screen after we walk through all that? Art, you tell me since this was your question.
It should be 3, 2, 1 done.
Yep, exactly.
And I think you can get 0 if you change the print statement on 13 to the to n, right? So
Yep.
just be 3, 2, 1, 0.
Yep, we can do that. We can just print n as well. Well, yeah, if you want to do it that way. I decided I wanted to do done. So dealer's choice. But yes, this is how recursion works, is our recursive case is going to break down the problem, break down that problem into different, I guess, smaller increments or it's trying to walk towards when you'll be finished with the problem. Okay. See lots of blank faces. Are we kind of following this, though, at least, how this works? And then let's bring up the terminal. Let's run it for good posture here and just watch it on the screen. I'm just going to cheat and play my play. Oh, of course, I would need to call it, right? Let's call it with a print statement so we can see what we're doing. Oh, no, I don't. Okay. Do I have to call it with a print statement?
No, you don't. No, you don't.
We have print statements written in. I'm just on autopilot here, printing out my function calls. Okay, so we're going to call countdown with 3, just so it's not going too long. Okay. Here we go. 3, 2, 1, done. Awesome. All right. Has anybody used the debugger before in VS Code? Nope. Okay. I'm going to show you how to do this because it's kind of handy to see how recursion actually works. No, we're gonna do one more sample. It's better to walk through the next example and then I'll show you it. Yeah, we'll move on to another example first. Okay, so we got how we're stepping down here to a simpler, basically decrementing our number each time to reach this 0 case. So this is kind of easy to follow, but there are some other ones that maybe might not be as simple to grasp when you're trying to figure out a base case for your recursion here. So on to the next problem. This is a very common one though, another very simple one to walk through, but I want to just be able to call a function, and I want to give it a number, and I want it to add all numbers up to this number that I give it. So basically adding all the numbers in range of this number. All right. So let's think about basically the simplest input we can have. If we want to add every single number up to the number we put in, what is the easiest input to give us like our most simple response basically or return? If I pass in 5, it's going to want to do 1 + 2 + 3 + 4 + 5, or inclusive, I guess. Yes, we'll do inclusive.
Are you asking for the return?
I'm asking for our base case, and I want somebody else
base
besides Cisco to tell me. So I'm looking for what's the simplest input we could put in here and get like the easiest response, basically. If I want to add all numbers up to that number I put in. What happens if I put in 2? Then it's going to want to add 1 + 2. Is that the simplest I could do? It's kind of tricky thinking of these base cases. What's the easiest number to add? Once you get it, you'll get it.
Maybe just 1, like 1 + 1 would be in that range, right?
Well, even just 1. If I just give this a 1, there's no other numbers besides 0, maybe, if we wanted to account for 0. But there's nothing else we can add with 1. Like I didn't give it any other numbers. 1 is the smallest amount that I can give it. I can also give it 0. If we gave it 0, it's just gonna return 0 because adding everything up until that number, there's nothing before it. All right. So that was good. Perfect, Art. 1. We're going to use 1 as our base case. So I want to basically say if we get a 1, return 1, right? Because if we add every other number up until 1, then it's 0 + 1. Okay, so 1. So how can I write this base case here? Look up here if you need a little example of how I write a base case. And somebody take a stab at it.
If n = 0, print done.
Oh, we're gonna go to 0. Okay, we'll go
I'm
0.
sorry, if n = 1, my bad.
Both are acceptable, both are easy base cases. So yes, we're gonna do if n = 0, should I do, oh, sorry. I usually work in C# and other stuff, so sometimes the syntax gets me here with these equals and whatnot. So if n = 0, we want to, what do we want to return? Or sorry, n = 1. I'm sorry, I missed.
Done, or what, I mean, whatever we want.
So if I want to add all the numbers up to 1, what should I return? I don't want to return done because that doesn't give me the
You want to
sum.
return the sum of them.
Yes. So if I put in 1, what's the sum of 1? For lack of a better.
1.
Yep, exactly. I want to return 1. Because we want the sum. We want to add everything up. So if I give 1, I want a 1 in response. Because that's my sum. Awesome. So we've accounted for this most simple form of this function by passing in a 1. Now, what happens if I pass in a larger number? How can we approach this to basically step down or up, whatever, break it down to get to 1? So let's start with our else. I'm going to get you to start thinking about this here. Okay, so if we want to add everything up until, let's just start with 4. We want to add everything up until 4. So I'm going to put in a 4 here. Okay. 4 doesn't hit this, so that's not going to work. So I want to add 4 to everything else that comes before it, right? So how can we add 4 to every other number before it? Let's just start with, I mean, logically, we want to add 4 to whatever we do to figure out the rest of the numbers, right? So let's just start with, we're going to add that number. We're going to assign this to a variable because I don't know what we're doing yet. Okay, so I want to take 4, we're passing in 4, and I want to add it to every other number that comes after it. Okay, so how do I get, well, I can't result it right there. We'll come to that in a second. How do I get the next number in line and make sure that we add that to this number?
I thought we needed an if statement here. Like if n is greater than 1, then add 4. Is that what we're talking about?
So it's our else. So we're catching every other scenario, basically. This is a bad, here, let me change that else. Usually you have an else, but you can have multiple ifs, yes. But we're starting with the simplest recursion examples we can. So we're learning an if else sort of thing here. If it hits this base case, you're pretty much done. Otherwise, do this stuff to try to work it down to that base case. Okay, so this is where we're going to start seeing how recursion actually forms this kind of like placeholder call stack. And it's behind the scenes, and you don't see it happening unless if you do the debugger, which we'll walk through. But so we know if we did this calling the function again with the number less than it, we can make it do some things. So let's just kind of roll with that. So I want to do n plus 3 and whatever comes after 3, right? So how can we get to 3? We can get 3 by doing n minus 1. But if we just stop there, we don't have all the rest of the numbers in the mix, right? We just stop with 3 then. And then we're stuck. We can't go anywhere. So we need a way to not only get that 3 added to n or 4, but we also need a way to get the other numbers that come after it, which we can do cursively, where this is going to be just hang in there, hang in there. It's So I am going to try calling this again with the next number down because I just want to see what happens. And now I can see I don't want a result. I'm just going to return this so that it can do its thing here. Okay, so now we have n plus, so if we pass in 4, we have 4 plus whatever the sum of the rest of them are, basically. Because we've built this function to find us the sum of all the numbers, all right? So here I'm saying I want n plus the sum of all the rest of the numbers. But one step down, we're passing in the next one down. So let's walk through this. Okay, pass in 4. We come here, 4 plus, let's call it again with 3. So this is going to give us, I'm going to put what this is doing at each level right here so you can follow along. So the first one through, if I pass in 4, it's saying, okay, cool. That's going to give me 4 plus this sum of range 3, right? Because we've told it we want to call it again with n minus 1. So now the next time I run it, if I pass in 3, it's going to come down here because it doesn't equal 1, and it's going to say, all right, now we've got 3 plus the sum of, or the sum range of 2. And we're like, whoa, wait, so what's happening here? Why, like, now I'm going down to 3 plus sum range 2. What's going on up here with this sum range 3? This is just hanging out. This is the call stack. So each time we're calling, like right here, when I got this return, basically, this 4 plus sum range of 3, it's saying, cool, I know 4, but I don't know this yet. I can't give you a value for this because I haven't worked it out yet. So let's just put a pin in it and run it again. So then it gets to the next step and it's like, okay, now I can give you the value for that. There's the value of sum of 3 or sum range of 3 plus, but oh no, I have another one that I can't quite give you that yet. So let's save it and we'll move on to the next step. So now the next step, we're like, okay, we've got a 2 now because remember we pass in 2. So we're going to put down 2 plus the sum of the rest of them, some of these. And we're going to give it 1. So now when we run sum range with 1, thank you to our base case, comes down here and says, okay, 1 equals 1. So I'm going to give you 1, and that's it. So on the last run of this, it gives you 1. Once it reaches this base case and stops with just a single value, that's when it starts filling it in back up the call stack. So here it finally resolved all the way down to the very end, our base case, and it says, all right, cool. So this sum range 1, hey, I've got a value for you now, that's 1. So it'll basically overwrite that and give you 1. And then I'll say, okay, so 2 plus 1 is 3. Hey, that was what sum range 2 is when I evaluated that. It's 3 because I've added with the value I got from that line. So it gives you 3. And then here, the sum range of 3 says, oh, I've got that now because I got the value from the other one, is going to go ahead and give me 6. So put 6 in there. And then finally, it gives you 4 plus 6, which equals 10. And that's going to be your final return from this recursive function. You see how that kind of works? So recursion kind of seems a little abstract, but it makes sense. The computer cannot, like, nothing can process a function until it's finished getting all its values. This doesn't have a value until it's finished at the base case. Then all of a sudden it has a value. And then it keeps filling in those values backwards to the very beginning. We can see this stepping through the debugger. Let's see if we can do this. It's been a minute since I've opened the debugger, so I'm going to call sum range. And if anybody has any questions, confusions, whatever, go ahead and, I know this is a very interesting topic and it's hard to explain, but I'm going to try to give as many examples as I can here. Try to hopefully help it click. And thankfully your challenges today are not as difficult. And these will apply to the challenges. So let's go ahead and do the same we did here, sum range 4. Okay, so if you haven't used the debugger in VS Code, it's this run and debug here. It's got a little bug in your play button. In order to run this, you need to have a breakpoint, which when you hover on the side here, this little red dot, that's your breakpoint. That's basically where you're telling it to, all right, stop there. And then I'm going to go ahead and step through the rest of the program or the function. So I'm going to put a breakpoint in here because I want to see every time this value changes on the side here. So once you get your breakpoint in, so if you don't have a breakpoint, you'll know. You'll push run and debug. Yes, Python file. And it won't do anything. It'll go so fast because it just did the problem or the function and it's done. But it didn't show you anything. So if that happens, make sure you have a breakpoint in. Okay, so I'm putting a breakpoint here right away on it if n equals 1. So now what happens? I push run and debug. All of a sudden, everything stops. We have a whole bunch of different things we can look at. It's highlighting the line that it's stopped on currently right now. Ooh. Hey, this is cool. This n equals 4. I haven't seen that before. On the side here, you will see any variables that you've defined within your function. So we said n equals 4 when we passed it in, when we called it here, right? So nothing has happened to manipulate it yet. It's hit this first breakpoint and we can see n is equal to 4. So now what you can do is over here in the middle, we have this handy step through. Basically, let's see if you can continue, which will just keep running it to the next breakpoint. Or you could step over, step into, step out, a whole bunch of stuff, restart, stop. I like to just step into. So when you step into, so it hit that first one, n equals 4, and it evaluated that and said, nah, that doesn't fit. So came down to the else statement. Now in the else statement, it's going to go ahead and do the plug in the n equals 4 and run this. So let's see what happens here. Let's step in. Look, there's some weird things happening down here. I don't know what's going on. Well, I do, but we can see some things are stacking up over here. Kind of like what I was saying happens here, where we're having some placeholders being saved because we've called this function again, and there's values that are missing for us to be able to finish this function. So this right here is where you will see the call stack kind of working up and holding these placeholder expressions, basically. But we can see once it ran the sum range n-1 and put another little call stack down here and came back up top and it's hit our breakpoint, we can see n equals 3 now. That's because we did the n-1 there. So now the new n is equal to 3. Oops, I don't want to step back. I'm going to step forward. Okay. And now it hit this. So it went through so fast because it's not meeting this criteria. It went back down to 2. We can see another little stack got added over there. And then right here, we have now n equals 1. So this should work this time and return 1 at this point. So let's hit that. Look, it's going. It's hitting that now. It's going to return 1. Now, when it returned 1, it's kind of doing some weird things here now. You saw one of the call stacks disappeared. And that's because it's now going to kind of work through the rest of these placeholders. And there's another one went away. It's doing that plugging in. It's taking that value that we got and plugging it in each call stack here and taking it off. And the other one goes away. And then we're left with our return once they all resolve down here in this stack and we get our 10. But this is a way you could step through recursion if you can't quite see what's happening to the variable you've passed into the function and how that call stack's building up. Kind of a fun way to kind of step through it. Any questions right now? I have one more example to go through. And again, today we're just touching on this and learning it for the first time. Saturday, you're going to go into more depth with this. We kind of following, this is what really helped me, is kind of seeing how each run of this goes. And I'll be honest, trying to figure out those base cases can sometimes be difficult. So I don't blame you there. So next example. I want to do the same thing. Like I want to add everything up. But this time I want to do it in a list. Instead of, I want to pass in a list of numbers and I want to add everything up in the list instead of doing just a number and it working through that range. So this kind of adds a little complexity, but I'm gonna go ahead and take a look at that. So we're gonna call this sum range again. I like that. No, sum of a list. We're gonna call this sum of a list. Let's be a little more descriptive with our names of our functions. Sum of a list. We want to pass in a list of numbers, okay? Cool. I got this list of numbers. So let's think about our base case. I'm going to put up here our input so we can try to visualize what might be the best base case. So if I'm passing in like that, we're going to just go to 4 because that's the easiest. And then I expect the output to be 10. Okay. So let's think about what is the easiest or the most simple form of this problem. I want to, or function, I want to pass in a list and I want to get the sum of that list. So let's think about it. If I pass in a list of 2 values, then I'd have to add 2 things together. That sounds pretty simple, but there's got to be something more simple than that. Adam, haven't heard from you much. Calling you out. What is an example of maybe like, let's try to think of the most simple input we can do for this. If I want to add everything in a list.
Then you could just do sum and then in parentheses the list, the name of the list.
So what do I want this list to look like? Like what would be the easiest version of this list for me to solve if I want to add everything up in it? Does that make sense?
I don't know if I'm tracking that well
Okay.
right now.
So like I said, yeah, base cases are always kind of difficult to think about. Like what's the easiest thing I can throw in and what will it give me? That's not sometimes so intuitive. Let's just play around a bit. Okay, so if I want to pass it, maybe if I pass in 2 numbers in a list. So then if I do that, then I'd have to add those 2 together, which we could do, but I think there's got to be something even easier than passing in 2 numbers in a list. Anybody else want to take a stab?
This might be ridiculous, but if it's a list, what if you do the index 0 for the beginning of the list?
Okay, like where you're headed, that you're just thinking of grabbing that first value, right? You want to do like a number 0, right? So let's look at what we could put in that maybe would kind of replicate this without us having to target in a like long list of values. So if I like this would be the easiest, right? If I could just target one number, because then adding that is kind of like above we did. If we just hit 1, that's easy. You know, adding everything up to 1 is just 1. So if I could just have one number here, but if I just have like maybe that number is like a 10, that's still kind of a difficult thing because I'd still have to add all the way up to the number. What would be the easiest number to add? We touched on this in the last one. We said 1, but there was another number that's also very easy.
0.
0. So I want to try to get to a place where I don't have to do any addition. I just want to either return 0 or nothing. So with a list, that kind of looks a little different, right? I can't just grab a number because who knows what number that's going to be in the list. It could be a 10. But what if I just gave it an empty list? Then what is my solution? If I try to add everything in this list, what is that? There's nothing to add. It's going to be a big fat 0. So with lists, oftentimes the most simple input you can give in a recursive case, or as a base case in a recursive function, is probably going to be an empty list, because can't get much easier than an empty list. I'll just give you back nothing. All right. If you give me an empty list, I'm going to give you nothing. So let's use that as our base case. It's super simple. You give me an empty list, I give you nothing. Okay, so how do we identify if this list is empty? Think back to oh, if you're talking Cisco, you're muted.
I see. So you're gonna do if len parentheses nums equals 0.
What is this saying? Somebody else tell me what that's saying.
It's going through the length of the entire list, like all the numbers in the list. And if it equals 0, then you're good.
Yep, exactly. Len of the numbers is just counting how many are in that list, and an empty list would be 0. Perfect. So if the length of that list is 0, then like we said, if I give you nothing, you're going to give me nothing in return. That's just, so we're going to return 0. Empty list, nothing to add, will give me a 0. Perfect. So there is our base case. Now we need to figure out how to break down this list each time. Let's not think about what we're going to do with everything in this list. Let's just think about how can we break down this list every time. Like, how can we make this smaller? What can we do to make this smaller? So if I'm basically looking for something. If I have this list of 1, 2, 3, 4, I want to be able to basically kind of make it into like, let's say 2, 3, 4, right? I want to break it down. I want to make it smaller each time. And then the next time, maybe just 3 and 4. Now I want to make this list smaller. So how can I make this list smaller? What kind of Python features can we utilize to make this list smaller?
Can you join them?
Joining, would that make it smaller or larger?
Oh.
Probably larger, but let's see, what else can we do? Let's think about all the ways we can break something apart. How do we
Reduce.
reduce? Okay, that's getting fancy. We could use reduce. Reduce though is like kind of cheating. That will give us kind of that's gonna give us the answer. But we want to figure it out recursively, not using reduce. So that is definitely one way to add all the numbers in the list together. But okay, so how do I break apart a list? Think back to our early days of learning Python stuff. Google it if you don't know. Super easy. Like split up Python list. Let's see what that says. Simplest way to split a list in Python is slicing with the colon operator. Cool. So we did this last week. Remember, we can do a list, and then we did all sorts of stuff with colon in here and set. It's like, where is it? Again, if you don't remember, you can always look at the syntax.
Double colon one
Okay, so
or
what
minus one or
okay, so what does this do? Okay, we'll look at it with numbers. What is that double colon one telling this? Here, let's also get in our else so we can.
Saying start, stop in the iterative.
Okay, so default start, if we don't pass in a value, the start is always going to be at the beginning. And then the stop is the end. So I don't know if we want to do this because if we start at the beginning of the list and then let's see, is it iterative?
I don't know if that's the correct word for it, but
Let's look up slicing and Python.
it's your step or yeah. It's
Yeah, your start and stop and step. Okay,
thanks,
so
Cisco. You always got my back.
I mean iterating, so
you
that
were
did
the
work.
same thing. Yeah.
Yeah. So in this one, we don't have a start or a stop. So it's just going to give us the whole list.
Mhm.
It's just, and it's stepping through the list by one each time, and it's just going to give us the whole thing. So if we want to break this down each time to something smaller, maybe let's say starting with the second number, what would we put in here then for our start stop? So if I want to just take this part of the list, I don't want the whole thing. I want to take a smaller chunk of it.
The start would be at 1.
Yep. And then stop, if we don't identify it, default, it's going to be the end of the list, so we can do that. We can go ahead and leave the one in there. That's fine. That's telling it to, step by one each time, but you can also just leave default, which is step by one as well. So both ways work. So this now will slice my list up. So this here will give me 2 through 4, basically. But I want to add all these numbers together. So how can I grab a value from this list and then continue on with this kind of reducing it each time? So let's start with, how do I grab this number first? How can I grab this first number? Somebody no, Cisco, no. Do we remember how to grab, how do we target this in this?
Num index 0.
Okay, so yep, we want to grab the index 0. So how do I write that? Nums.
Num and then brackets 0.
Correct. Okay. So this is absolutely right. This is going to grab that first number in our list. This is going to grab 1. And we want to do 1 plus every other number in this list, right? And we want to go all the way until we hit this empty list, which then will give us a 0. So kind of like how we did up here with our adding in the range, we're going to go ahead and take that first number plus everything else in that list. However, if I just leave this here like this, is this doing anything for me? Am I getting anywhere with this? If I pass in this list, it comes here, it says, okay, length of this list is definitely bigger than 0, so let's come down here. Okay, add that first number and then the rest of the list. And then it stops. Doesn't do anything for me, right?
You need another return statement?
Yep, we can return this, yes. But how can I get this to keep going? I want to keep adding all these things together that I don't yet know because I haven't broken them out of this list yet. Give a hint with my cursor there. So we've identified this function that will go ahead and if I give it a list, it will give me that number, that first number out of the list. And then eventually when that list is empty, it will give me a 0. So I want a way to be able to grab every number out of this list until I reach 0.
Are you going to call the function again?
Yes, I want to call that function again because I already wrote a function that if I pass it a list, it will give me that first number in the list. And then eventually when I get nothing in that list, it'll give me a 0. So I want to call that sum list again with the rest of the list. So here now we have 1, 2, 3, 4. We pass it in, it's longer, a long list, it comes down here, it says, okay, let's walk it through like we did up here. So the first time through, it's going to give me the first number in this list, right? We've grabbed it here, which is 1. And then it's going to add it to all the rest of the numbers that we haven't pulled out of the list yet. So we just go ahead and call that function again with the rest of the list, 2, 3, 4. Okay. These can't be added together yet. They're not at the same level. We have a function call here that doesn't have a value for it. So now we're doing this part. We've got sum of 2, 3, and 4. So that's going back up here in this list. Now we have numbers as 2, 3, 4. Still not an empty list. So we're going to come down here. Now we can see 2 is the first number in our list. So this is where we have 2. And I want to add, and then we've got this sum list and then the rest of the list basically. So sum list, oh, I didn't, it's called sum list. Sum list, and then the rest of the list, which right here we passed in 2, 3, 4. We took out 2. The rest of the list from that first index on is just 3, 4. So then we still haven't gotten a value here. We call this again. This time around, sum list of 3, 4. Still not empty, comes down here, pulls out the 3, as we told it to, and then returns call again with the rest of the list, which is 4. So now we have almost an empty list, but not quite. We still have a value in here. So we come up again, pass it in again. It says you have 4, so it's not empty. It's going to come down here, pull that first one out, which happens to be the only number this time. Thank goodness. However, now when we pull that out and take everything after that, that's going to be like empty. There's nothing left in this list, right? If we just take everything from it, so it's gonna give it this. Because there's nothing in there now after that number, after the index 0. So now we've hit our base case. It comes up here. We pass in an empty list and it said, oh, there is nothing in this list. Okay, I'm going to give you back 0. And then finally, once it does this, now we have values that we can plug in for every placeholder function call here of the stack. All right. How are we feeling about recursion?
I get it now. I was just being dumb.
It's okay to not get it now. Sometimes thinking about this, how you're going to call the function and break it down and that sort of thing can be a little difficult. So it's good to look back on similar problems we've done to try to figure out how you might kind of get what you want that way. Art, question?
Yeah. So this isn't creating a new list with just the results. This is just giving you the results of line 44. Um, I believe. So this is a little bit different than a for loop because I think if we wanted the results, then we would create a new list, name a new list,
Mhm.
and then put the result into that list, correct?
Yep, so that is like the more what are the imperative way of solving this, where you would iterate through each number in the list, kind of hold the value and add it to itself as you're looping through. But this is recursion's supposed to be a little bit more, I'd say simple, but it's not really, but it's supposed to be an easier way to work through the problem so you don't have to do this for loop. However, if you don't have a base case and then you blow your stack and you get the stack overflow error because you just didn't have an end. Here, let's do it. I, I don't know. I don't really think it's what does our thing say today for curriculum here? It's a different approach. I guess I'm not going to say it's more simple. It's just a different way to approach it. Sometimes it might, if you understand if and for loops and if stuff, like this is a normal way to solve something and it's fine. That works. Recursion is just showing you a different way to do that without maybe I don't want to say without so many lines because obviously it has just as many lines as that does. It's just a different way to do it. This is the best I can say.
It could replace for loops altogether, though.
Yes, it could in certain scenarios. And y'all will have practice with that on Saturday. Or maybe we have today. Actually, I have to look here, recursion. We'll look at these off recording though. You will get more
Tiffany,
practice replacing what you've done already with just for loops with a recursive type solution. Yes, Cisco.
I was just going to say, if you run through the debugger, you can. It's really cool how it kind of breaks down what's going on with the list as you're taking away each element. So that may help them. That may help everyone understand it too, what's going on.
Yes, 100%. And first, I'm going to show you what happens when you don't have a base case. I'm just gonna, let's see, where can I see this happening here? Did it? Yes, it was fine. That shouldn't have happened though. It should have just really, really not liked that. I don't know where it's telling me, yelling me about it. But we can see obviously, because I didn't call it. Okay, y'all need to yell at me sometimes. I actually need to call this function with an input.
Okay, it happens.
It's so much easier to be the observers than the actual coder. You'll find that out in pair programming. You'll see things others won't. So we need to pass in a list. Let's pass in our 1, 2, 3, 4. Now I'm gonna break this. Okay. And let's print it as well. What is going on here? Oh, I don't need that at the end. We're just going 1 to the end. We don't need a, no, index error out of range. Okay, let's troubleshoot. I know this is everybody's favorite thing to do. So let's look at this together. So what is this telling me is wrong with this problem? Do we know how to read error messages in our terminal? Starting at the bottom, typically, and working our way back up. So the very last thing here is we get list index out of range. Let's see. So that tells me something might be wrong with either the grabbing or the slicing afterwards. So I am looking at these. I don't see. Oh, well, because I don't have the base case to catch it. I guess I can't show with this one. Let me go back and we'll put the base case back in.
Right, it'll work fine.
Yeah, yeah. It's because we're missing the last instance where it's empty. Because then there's nothing in there, there's no index to grab. So that's what that error is saying. Hopefully y'all would have gotten there. But basically, when it's complaining of a list index out of range, it usually means it can't target a value in this list, either because the index doesn't exist at that point, or maybe you went too far and it's like 1 over what's actually, it doesn't exist usually. The index doesn't exist. So at this end here, when we're passing in empty, there's nothing in here. There's no index. I can't even do 0, like index 0. There's nothing. It's empty. So that's what it means. Couldn't grab it. Okay, let's run it now and we'll see it. Print. Some list. That's what happens when I go off script. But it's good practice. Y'all need to know how to figure out looking at what went wrong and figuring out how to solve it. So I will do that a lot. Let's go ahead and run this now. Print that and it'll just show me 10 because it works. But let's put it in our stop. Okay, we'll run and debug. Okay, so now we can see we put in this whole list here. Let's step to the next. It's going to hit this statement because it's longer than empty. We can see it's still 1, 2, 3, 4 at the beginning of that, but after it executes that line, we can see now that it is 2, 3, 4 because we split it up. And then down here in this call stack is where it's holding that first number, 1. It's holding it down here in the stack. It's not assigned to a variable. It's just floating there, waiting for everything. So now this next time it hits that, and again, chops the list down. Now it passes in 3 and 4, saving that other value in this call stack here. And it keeps doing this until we get to 4. Now 4, we pass this in here, returns that empty list because we took 4 out. It's being held in this call stack. And now it should equal this right here, empty list, which will go ahead and give us 0 in return. And now it's working its way back. So this is giving you the value that we had at the end, okay? So when we had that list that had 4 in it, it's working backwards through the stack and plugging in the values for this. Like this nums 4 is what's coming here. And it's adding it to that number it already had from before. We go to the next one. Okay, this is going to be kind of confusing, but now it's saying that, okay, now the next one in that list that we pulled out and found the value for is 3. So it's kind of putting it, don't worry that it's putting it in a list, but it's just kind of showing you that return sum list 4. Maybe this is a little bit better. Okay. So this is when it's resolving up the stack, and you can see at this point in the stack, it's plugging all the values in that it didn't have before. So this here was 4, and then the 0 value was 3. Sometimes this can be confusing. And now it's recreating the list. Oh, this is going to confuse you all, hopefully not. But we can see I was grabbing each value that it's solved for in the stack and plugging it in where it was in the list. Cisco, why do you have me do this?
Hey, you're doing great. I think so essentially I was just talking about the top part. Not, you decided to delve deeper into it than what I was.
Yeah, like it's
It's
trying
okay.
to watch the resolution of this call stack can sometimes be a little bit of a like mind
Yeah.
game.
Yeah, I just wanted you to show them how it was popping it off the original list so you can see the numbers
Stick to
just
that.
going, yeah.
It's basically doing this and taking those and plugging it in backwards, but I don't know why it's putting it in the list. There's got to be a reason, but then it's holding that sum of all those numbers too. You saw
Yeah.
it. So, all right, thanks.
Thank you.
It's again a really interesting concept to try to teach and get y'all to understand. But Saturday's lecture we'll definitely do some more visuals and more examples of other scenarios. I'm gonna stop recording. Let's see.